right, ladies and gents, we're on page 5 in our notes today. We're going to be graphing absolute value inequalities. So yesterday we graphed absolute value functions. Remember, those were the V-shaped function where we found the vertex, we plotted some points, and they ended up looking kind of like this. So today we're taking that and we're extending it a little bit. We're taking absolute value inequalities. So instead of f of x equals, we have y is greater than or y is less than. Okay, we did this with lines. Now we're going to do it with our V shapes. And here's the cool thing. Everything is just like what we did yesterday, plus that inequality piece. I think you're going to find this very doable. So you need a straight edge. You need a colored pencil. It does not have to have two sides. It can be any color you choose. If you don't want to use a colored pencil and you want to shade with your pencil, that's totally fine with me. And make sure you've got your calculator handy. So when we're graphing absolute value, the first most important thing is that we have to have our vertex in the middle of our table. We're going to create a table of points, vertex in the middle, some points on the left, some points on the right. Okay, we're going to create this table of values. So I'm looking at number 1 here. This says y is less than the absolute value of x plus 1. To find my vertex, I take the stuff that's on the inside. I set it equal to 0. And I solve for x. I'm going to subtract 1 from both sides. X equals -1. I'm going to put -1 in the middle of my table because that's where my V shape comes to a point. That's where my graph turns around and goes the other direction. Okay, now I need to have some points on each side of that. So I'm going to do some points to the left. -2, -3, -4. I need some points to the right. So 0, 1, and 2. I can use my calculator to calculate these. Math, absolute value. I'm going to put -4 in for x. X plus 1, enter, and I get 3. So I'm going to put 3 right here. Now, if you want to mental math it, you can mental math it. -3 goes in for x. -3 plus 1 is -2. The absolute value of -2 is 2. And we're going to fill in the whole table this way. So go ahead and, whichever way you like, work your way through that table. The absolute value of -2 plus 1 is -1, which gives me +1, 0, 1. Okay, I have my table of values. I'm going to plot them. -4, +3, -3, +2, -2, +1, -1, 0. Notice when I hit that vertex, I bounced and I started going in the opposite direction. Okay, so now we're going to graph this, but this is an inequality. It's not equal to. So we've got to pay attention to whether we need a dashed line or a solid line. Remember, if it's greater than or less than, we use a dotted line. If it's or equal to, we use a solid line. This says y is less than, so we are using a dotted line for our V-shaped graph. What this means, points that are on the line aren't part of the solution set. Only the points in the shaded region. If we have a solid line, the solid line is also points in the solution set. Okay, we did our table of values. We graphed it. Now we're going to shade. We have y on the left. This says y is less than. I'm thinking of my y number line, which has big numbers on top and little numbers on the bottom. If y is less than the V shape, y is under the V shape, that's this end of my graph, So I shade underneath. Now, all of the points in the shaded region are solutions that make the math work in this particular inequality. So if we want to check our work, I'm just going to pick a point. I'm actually going to pick the origin because it's in the shaded region. My origin is 0, 0. I'm going to put it in for x and y, and I'm going to see if the math is true. 0 is less than the absolute value of 0 plus 1. I'm going to do the math here. The absolute value of 1, 0 is less than 1. True or false? True, yes. 0 is less than 1. That's true. That means, yes, this point is in the shaded region. If I did my math and it didn't work, I'd go, I might have my shading wrong. I'd better double check that. All right. Let's try another one. Number 2, y is greater than or equal to x minus 5, no, the absolute value of x minus 5 minus 2. So we're going to start by finding the vertex. We take only what's inside the bars, okay? I'm ignoring everything on the outside for a minute. Inside the bars, I have x minus 5 equals 0. Set it equal to 0. Solve for x. X equals positive 5. Positive 5 goes in my table.
Physics news interruption. Justin Old.
All right. So I've got 5 in the middle of my table because that's my vertex point. Now I'm going to want some points on each side of that. So I'm going to go 5, 4, 3, 2, and 5, 6, 7, 8. I just count in each direction. And now I'm going to put each of these x values in for x in my equation, and I'm going to calculate it to get my output. So I've got absolute value, x minus 5 on the inside, minus 2 on the outside. So make a connection right here. We did not use the minus 2 to find the vertex because it's outside of the bars. We do use the minus 2 when we're evaluating those points, including the vertex. Okay, so this gives me a 1. We're going to do this again with a 3 on the inside. That gives me a 0. Again with a 4. Negative 1. Go ahead and continue filling in your table, please. All right, once we've got our table, and we can tell by looking, look, it seems to be reflecting quite nicely. I feel good about the math that I did. We're going to plot our points. I'm going to start with the 2, 1, 3, 0, 4, negative 1, and then we have our vertex, 5, negative 2. So we should see it bounce right here. 6, negative 1, 7, 0, 8, 1. Okay, so there's our shape. There's our dots. Now we're going to make our line. We're going to graph our lines. Y is greater than or equal to. I'm going to use solid lines because it's or equal to. This means the points on the line work for solutions and the points in the shaded region work for solutions. Okay, there's my line. Now I've got to shade it. So I'm going to look at that inequality. This says y is greater than. The big y values, the places where y is bigger, is at the top of the y-axis. Big numbers are up, little numbers are down. If y is bigger, we're going to shade this part of my graph. Whether it's inside or outside, whichever way this faces.
Football players.
So we're shading where y is greater, above our graph. Okay, it's not about inside, outside. It's about the y-axis above or the y-axis below. Keep that in mind. All right, let's try number 3. We want to start by finding our vertex. We're going to take what's inside the absolute value bars and set it equal to 0. We'll solve for x. We're going to subtract 6 from both sides. We're going to divide by 4 on both sides. We're going to simplify our fraction. And we're going to put -3 halves in the middle of our table. Now remember, we had one yesterday where we had a fraction in the middle of our table. That's okay. It might mean our points don't look like a perfect reflection until we've graphed it. It's still going to work out. Trust the process. Okay, fractions are okay. So now from here, I'm going to switch to integers. So this is -3 halves, -1.5. So I'm going to go -2, -3, and -4. And on the other side, -1 and 0 and 1. And this one is actually going to look like a good reflection because 1.5 is in between 1 and 2. So let's grab our calculators and we're just going to plug each point in to fill in our table. All right, so we're filling in this table with the points that we're calculating. These are our inputs for x. We're going to put them into absolute value here, calculate. It's going to give us our output for y. So absolute value. -4 times -4 for x plus 6, and I get 10. Absolute value, 4 times -3 plus 6, I get 6. Put in a -2, we'll get 2. 4 times -3 halves in parentheses. Always put your fractions in parentheses. Plus 6 gives me 0. And we'll just finish it out here. And I notice that my points are reflecting nicely on each side. So we're going to graph this. -4. 10 is off my page. -2, 2. -3 halves. That's -1.5. So it's in between -1 and -2, halfway in between on the axis, and then we're going to bounce back up. -1, 2, 0, 6, and that next one is off the page again. Okay, we're going to draw our lines here. Y is greater than the equation, so we're going to use dotted lines. Like so. And my inequality says y is greater than, so I'm looking at the y-axis. The greater part of the y-axis is this part right here. So wherever that happens to fall on my graph, that's what I'm shading. So right here, I end up shading above. All right, let's try number 4. We're going to start by taking just the inside of the absolute value bars to find our vertex. It says 2x equals 0. Notice I'm ignoring the negative. I'm ignoring the +3 right now. Divide both sides by 0. I get x equals 0. So my vertex is going to be right in the center of the graph. Now I need some points on each side. -1, -2, -3, 1, 2, and 3. Now, when you're filling in, and you're using your calculator to fill in your points, be really mindful you have a negative sign, and then you have your absolute value bars. Inside your absolute value bars, you have 2 times x, and you're putting your x in parentheses, and then you're going to push over to get outside your absolute value bars, plus 3. I got negative 3. Go ahead and use that. Finish out that table, please. And check your table with my table, see how you did. Make sure our points are lining up. Make sure that at that vertex it's bouncing and going back in the opposite direction, so we have that reflection that we're looking for. And now we're going to graph negative 3, negative 3, negative 2, negative 1, negative 1, positive 1, 0, positive 3, 1, 1, 2, negative 1, 3, negative 3. So notice we have an upside down V shape this time. That's okay. Actually, anytime we see this extra negative out in front, it's going to give us that upside down V shape. So now let's connect our lines, and we're going to check our symbol. This says y is less than or equal to. Equal to means we're using a solid line. So we're going to go down each side right here with a solid line. And let's shade. So this says y is less. Okay, y is less. Little less is at the bottom of our graph. So inside or outside doesn't matter. It's above or below. This says y is less. That means we're on the y-axis underneath the graph. So we're going to shade below. Like so. Okay, try number 5 on your own, please. I'm going to work my way through it also, but check your skills to see where you're at. Okay, when you've got 5, glance at the screen and check your work. If you've got 5, try 6. If you're struggling with 5, turn to a friend, please. Ask a neighbor. compare your work, see if you can help get each other squared away. But I have a feeling you're doing pretty well with this. If you've got 5, try 6. All right, I've got 6 finished. So when you're ready, check your work, see how you did. That's the extent of our notes for today. So your options for the rest of class, and you have to choose one of these. You can work on Delta Math, piecewise functions, or you can work on IXL, absolute value. I think it says graphing absolute value or absolute value graphs, but it's under teacher recommendation. So you choose either activity to work on for extra practice. Please do math until the end of the class period. Please make sure that your Delta Math piecewise functions is complete so you get full points on that. And I will see you guys on Monday.